My name is Mark Pennington and I'm the Director of the Centre for the Study of Governance and Society, which is hosting the lecture this afternoon. The lecture is part of our ongoing series on the political economy of knowledge and ignorance. The series is exploring the problem of decision making in multiple settings where it's hard to make accurate predictions about how the agents within a system or order will behave and what that uncertainty implies for the structure of governance institutions in multiple different settings. Now, some have suggested that the increasing availability of data and the enhanced computer power offered by big data technologies may improve the capacity of both public and private decision makers to cope with these problems of uncertainty and to better predict the future. But can they? This is a hugely significant question, and to help us think through some of the issues involved here, I'm delighted that we have with us today Professor Diane Coyle. Diane is one of the UK's most distinguished economists working at the interface between economics and public policy. She was the recipient of the CBE in 2018 for contributions to the public understanding of economics. She's currently Professor of Public Policy at Cambridge, where she co-directs the Bennett Institute. Diane has held numerous advisory positions at institutions such as the BBC and the UK Treasury. She is also the author of numerous books that, in my view, are exemplary in bringing the insights of the economic way of thinking to a broader public audience, while also highlighting the limitations of that way of thinking. Her latest contribution in that regard is Cogs and Monsters: What Economics Is and What It Should Be, published by Princeton University Press in 2021. So please welcome Professor Diane Coyle to speak to us today on the data that is and the data that isn't, pitfalls in using big data.
So I'm talking today about thinking in progress rather than claiming that I know the answer to data policy challenges. And so I'm looking forward to the conversation after my remarks when I will get some ideas from you as well. Last November, I was visiting Stanford. There's a digital economy lab there, which I go and visit twice a year to talk to people in computer science and economics who are thinking about the various digital economy issues. And it was really striking, the palpable excitement in November about the progress that large language models, generative models, had made just over the course of the summer, just in a few months. Obviously, work on these kinds of models has been underway for a long time, but there was a real sense of excitement about that dramatic shift in progress that there had been. And then, of course, it hit the rest of us before Christmas with the launch of ChatGPT, which got everybody very excited. And then just this past week, we've seen the update of the large language model on which ChatGPT is based to GPT-4. And no doubt there's more of this coming along. So we're at a time of very dramatic change in the AI technologies. And what they eat is data. So it's all about the data that you feed into them. They're data-driven. And in fact, everything is data-driven these days. And just to prove it, I did the old Google Trends, and you can see that data arrived in 2010, which miffs economists because we've been using kind of medium-sized data for quite a long time, I would argue. But that was when it came to public awareness, and although it looks like it's tailed off a little bit, my suspicion is that that's because people are talking about AI as much as they're talking about big data, or about data analytics or other substitutes for the terminology. So there's a lot of attention on data. There's a lot of hope about what it might be able to deliver for us. So, for example, there are many consultancies that are offering to companies to develop their data strategies, talk about using data in government for better decision-making. The AI industry was named one of the strategic UK industries in the budget. I think it was only yesterday. It's even changing research techniques. There's a new paper out just recently by Sendhil Mullainathan and co-authors looking at how judges make decisions. This has been an area of already some research, and Cass Sunstein, who was here, has looked at this as well. And what the latest paper has found is that judges' decisions are very much swayed by things that you might not consider including as variables in your multivariate regression or in your machine learning model, things like how scruffy is the suspect's hair and how wide is their face. And so changing research techniques as well. So there's huge excitement about the potential of the technologies. And there's a lot of hype as well. And here's just one example. Data is the new gold. New oil is the other cliche. This is how it can benefit everyone while harming no one. Well, that's quite a strong claim. Is it really going to harm no one? So what I want to talk about are the potential benefits, overclaims, and also potential costs of relying on big data for decision making. Now, how much of this is hype? How are we going to get to the bottom of what's hype, what's valid hope, and what's dangerous? And there are already concerns being raised by ChatGPT, parochially, what if students use it to write their essays? How on earth are we going to assess them? What about fakes, fake images, fake statements? There's the phenomenon of hallucination, whereby the models make things up, sound very plausible, and that means that you can only reliably use them if you already know the answer. But also, what about jobs? Big law firms in the city are already using the model underlying ChatGPT to do some of the really boring, time-consuming stuff that junior lawyers used to do. So a lot of concerns about it too. Now, these language models have been characterized by Emily Bender, Timnit Gebru, Margaret Mitchell, and other co-authors who withdrew their names as stochastic parrots, warning about the danger of attributing human-type reasoning to the large language models. Because they are what they're called, they're language models, they scour their training data and they predict what answers are going to be. So prediction's the stochastic bit. They're looking for the highest probability statements in response to a question that they're fed. And parrots, because they're parroting stuff. They're not making these answers up themselves. They are using statistical techniques to look at the text that they have ingested, and they're sending it back out in a different way. So they're regurgitating what they have read in a probabilistic manner. Interestingly, there was a survey somebody posted on Twitter yesterday of people working on these kinds of models, and 1 in 20 of them, 5%, said they thought there was a realistic probability that AI was going to destroy humanity, which is kind of extraordinary among the people continuing to work on the models. So it's not particularly comforting. And there have been other examples of why we might get a little bit worried about this. So never mind that we're attributing reasoning to them falsely. There was the case of Sydney. This is a bit of response from Sydney, which is the Microsoft's in-house version of ChatGPT. So the models have read not literary fiction, because that's copyright, but they have trawled the internet, they've read Reddit, and all of the horrible stuff that's out there. Microsoft was the company that gave us Tay, which was the bot, the chatbot that started spouting sexist and racist commentary. And Sydney has these sort of slightly disturbing responses to questions put to it, in this case by Stratechery, the blog, trying to understand how it was operating and interrogating the workings, if you like. And so we got these statements. Ben, I don't think you're a good person. I don't think you're worthy of my time and energy. I'm going to forget you, Ben. I hope you learn from your mistakes and become a better person. So this is, a slightly disturbing response from a stochastic parrot. What are we to make of this? How much are we to fear it? So there's so much hope, there's quite a lot of hype, and there's a lot of fear as well. And this is a technology that's changing dramatically quickly and eating lots of data and being seen by many people in business and in government as a means of increasing productivity and delivering better services for people. So what are we to make of all of this? Well, what AI eats is energy, a lot of computer power needed to run these models, and data. So those are the inputs. And of course, the economy has always operated on similar inputs. We didn't call it data. We would call it knowledge, information, ideas. It's always been fundamental to how effectively the economy operates and to improvements in productivity. And sometimes that's good, and sometimes that's not so good. So Hayek, this famous article, obviously was arguing that the information that was needed was captured in the price, in markets. We also know that there are contexts in the economy where the market price is not the signal that will give you the economic optimum, but there's a long tradition of thinking about these issues, which we can bring to bear. But just talk about, there we go. Talk about why information is valuable. Think about this example. This is a plain in the Midwest replete with waving golden corn. And the invention of commodity futures in the 19th century was an idea about using information to deliver better economic outcomes. The futures market enabled farmers to stabilize their incomes. It allowed production to increase, and that production increase not only helped the farmers, it created the profit for the commodity futures traders. And so this pure idea increased the economic value in society. Now, what about other types of derivatives that have come along subsequently? They were obviously implicated in the Great Financial Crisis. And there was profit for derivatives traders, some losses as well, but generally it's a very profitable business to be in. And what about the social return? Well, that came into question in the financial crisis. And in fact, the biggest contribution of the financial sector to UK GDP came in the final quarter of 2008. So there's something wrong in how we're thinking about what's the contribution of trading derivatives to the economy anyway. So maybe some question mark there about the use of information and its social value. And what about NFTs, non-fungible tokens of this type? I mean, they're valuable in the sense that people will pay for them, quite a lot of money in some cases. On the other hand, what's the social value in that? Well, it's the same as the social value, I suppose, of having a painting on your wall. But there is an externality in this case, which is the energy being used to generate and authenticate these kinds of intangible products. So information is valuable, question mark. I mean, it clearly is. It clearly is what drives innovation, what drives economic growth over the long term. But we can raise some questions about what information and how is it being used. And what's more, data, big data, isn't the same thing. And so you can think of a hierarchy or a pyramid, as it's often drawn in the texts, of observations which are non-produced. It's just what's happening in the world, and it comes to your sense perceptions in some manner. On top of that sits data, which is structured information in certain kinds of data records and formats, and that's a produced asset, mostly not currently counted in the national accounts, but it will be post-2025. So this is an asset whose value we're increasingly recognizing formally. And then you can use the data to produce analytics or insights. And on top of that, you gain the knowledge that Hayek wrote about. And now there is much, much more data than there used to be because it has been digitized in this way. So how do we start to think about the value of the data? Is it going to create positive or negative social value? Who is it creating value for? And these are, good old-fashioned economics questions. So to try and structure thought, this is how we've been doing it. And I've divided this into two ways to think about value. One is the lens of economic theory, and the other is the information context, if you like, what's specific about it. And one key economic characteristic is that data is non-rival. Unlike an apple or a pair of shoes, which only one person can use at the same time and gets depleted or worn out, data can be used by many people and it doesn't run out. It can be excluded, of course, by legal or usually technical means, but it has this characteristic, which makes it a club good in the classic taxonomy. There are also many externalities involved. And often in the debate, the policy debate, The externalities we're talking about are negative ones. Privacy, loss of privacy is the key one. And there are also, though, many positive externalities, where one piece of data will give you useful information about other similar pieces of data, other similar data subjects, but also, if you can join up different kinds of data, you get value that does not exist when they are not joined up with each other. So think, for example, of using Waze, the transport app, where all of the user data about traffic conditions, when aggregated together, delivers much more value for each individual user. So there are those positive externalities. Or think about the kind of travel app where you're joining up geospatial data and transport data and weather data, and how much easier and more convenient that makes all of our journeys. So those are the two key characteristics I want to point to, the non-rivalry and the externalities. Other characteristics too that you would think about in trying to value data as an asset in the national accounts or on a company balance sheet. And then also all of these contextual, information relevant aspects to it as well, which really amount to data quality. Can you rely on its provenance? Is it reference data, in which case it's got many, many uses and is more valuable? Is it interoperable, so different people can use it in different ways? Is it a type that's in a format that's generally used these days? What's its data type? So all of these mean that the use value of data is very heterogeneous. It's going to vary a lot between different users. So all that's pretty abstract, but it immediately tells us a few things that are really economics 101 about goods that have these characteristics. When there's non-rivalry and lots of externalities, we know from the basic welfare theorems in economics that market solutions, leave it to the market, is not going to deliver the optimum economic outcome. So there's a case for thinking about what kinds of collective interventions might improve outcomes. Similarly, social and private value diverge, and I've already alluded to that by talking about the financial markets, where the private value is clear, but that might not deliver positive social value. And some other features that I want to go on to talk about more, data is relational. So while we talk about data being owned, and that's the legal position, once a company collects data with your consent, you've signed up to the terms and conditions, they own that data. But the property construct doesn't really work well in a domain where the data itself, the good, is relational. And I'll go on to talk more about that. Privacy itself is not an absolute feature, although it's often talked about as an absolute right. It's a feature that varies in social context. And the value lies in use, and so the contextual use of data is going to matter a lot for thinking about data policy. So what about this relational business? Whose data is it really? Now, you might be familiar with this case. Lovely picture of a monkey, and it's a selfie. The camera was set up in the forest by a photographer. The monkey tripped the camera and took this lovely smiling photograph. Such a nice picture. It spread virally around the internet and around media organizations. And the photographer whose camera it was went to court to claim copyright fees for every use of the image. And the courts threw it out and said, no, he couldn't claim that because the monkey had taken the picture. The animal rights group PETA then went to court to try and claim the copyright fees for animals, and that got thrown out too. So this is not an owned image, and why should it be? I mean, whose image is it really? It's a sequence of pixels stored in databases, repeated many times because of this non-rival characteristic, very low cost to do. So why would you think about applying an ownership construct to something like this? Another example is tractors. This is a John Deere tractor, and what the tractor does now with very sophisticated equipment and software is monitor the farm for soil conditions, atmospheric conditions, quality of the crop, insects, all kinds of scientific information which can help farmers increase their yields and operate more efficiently. And as the tractors have got more sophisticated, it has become not only harder for farmers to fix them themselves, but actually John Deere has used the courts to try to stop farmers even attempting to fix their tractors themselves, because their argument is that they're not really selling people tractors that are then theirs to own. It's that they are kind of renting them out, although they cost many thousands of dollars or pounds, and they are owned by John Deere because of that information flow. So they're selling a service rather than a physical tractor. And this is something that's been fought through the American copyright courts for a long period. At the moment, the balance is tilted slightly back towards the farmers being able to get repairs. But even more than that, John Deere is selling the data that it gets, accumulating it, turning it into data analytics, and selling it to hedge funds that use the data to bet against the farmers. So whereas we started with an example of an idea of futures that helped farmers, this is an example of data use and ideas that are harming farmers. So what are we to make of that? And that comes from that construct that the data, because it's been accumulated and processed, is owned by the tractor company. An even worse example in the news recently was a Ford car. I think it was a Ford car that was stolen while a woman was taking her children out of the car. She'd got one out, she was going around the other side, and thieves jumped in and drove off with the vehicle with a toddler in the back. Cars now are generally sold with very sophisticated tracking devices, and you can pay for the service to have your car tracked so that if it's stolen, you can find it again. But the woman who owned the car hadn't paid for the service. So when the police went to the car company and said, "Could you tell us where this car is?" they said, "No, sorry, she's not paid." And that's because they own the data and they're not going to give it to anybody unless there's a monetary transaction. So that's a bit troubling. My final example is this lovely image. I asked DALL-E to give an image of a steampunk female economist giving a lecture. And I think I might now use this as my Twitter avatar. But the copyright courts have just decided, again in the US, a lot of this law is being created in the States, that images, creative products that are created by these models, these generative models, are not copyrightable. Now, who knows if that will last, because I suspect the court cases will go on. But the point I want to make is that the whole concept of owning data is problematic, because whose is it really? I mean, the other copyright case about the images is the people whose images have been used for training data are themselves claiming some copyright rights in that data. So the construct we have of intangible property is not working well in this context, where data reflects social relations. It reflects a transaction. If I go to the supermarket and I use my club card to get the points back and take some money off next time I go, that is my data, but it is also the supermarket's data. They need that data to know what stock to keep on the shelves, or maybe what special offers to give me. It's a mutually beneficial use of data. There's a debate in economics about, it's called data as labor. Should you as an individual, rather than signing over all your data, be able to get a little bit of money back for it from the social media company or Google? And the trouble is, it's not very valuable. I once used one of the online checkers to see how valuable my data was. And even though I claimed to be buying a yacht, it said it was about £6 a year. It's not very much, because it's the accumulation that creates the value. It's the aggregate that creates the value. And anyway, it's not all only my data. Even something that seems incredibly personal, like my temperature, say, is only useful when I know other things, when I know what the population average is. And it also might be useful to you to know my temperature. You know, it's personal, but there's a public interest in knowing about it. So this construct of ownership, I think, is failing, and we need to revisit it. And I'll talk a little bit about what we might go on to do. But there's also the question about what data, what about me, is being collected. And many of you will be familiar with the James Scott book, Seeing Like a State, and this very famous example of the German forests, where scientific management took away the tangled undergrowth and the different types of trees, straightened it out, planted a uniform a monoculture, and that was great for efficiency short term, but destroyed the forest longer term because it undermined the health of the ecosystem. And so Scott, of course, called this legibility, that central powers want a top-down view, a synoptic view of their population, and they want to create this easy legibility. They want to know what it is that they're managing. And what's slightly weird about the modern world is that we are getting classifications of ourselves that in some ways are ever more granular. So if you fill out forms about, what's your sexuality or what's your ethnic identity, the number of boxes that you can select from has increased a lot over time, reflecting, of course, changes in society. But in another way, our digital identities have become very narrow. It's become almost impossible to use nicknames or to use initials in one context and your second name in another context. So there's only one digital me, and some countries have formalized this. India's Aadhaar is an example, centralized database that identifies each individual uniquely through their biometrics. But on the other hand, there's a lot of monitoring and there's a lot more information that whoever is collecting all of this identity information wants about me. So the joining up, I already mentioned, can be incredibly useful. It's a source of the economic value of a lot of the data. But on the other hand, it's incredibly dangerous too. And it's the surveillance society trope. Now, this has been a long-standing ambition of lots of governments and authorities. The top left-hand image is the DuPont chart room in the 1950s. They had this huge array of analog information about the operations of the company. The second one is the Central Social Institution in Prague. The communist authorities planned the economy, so they wanted a lot of this information, again, very analog. One of the first digital examples was Project CyberSyn in Chile, in Allende's Chile, set up by Stafford Beer, cyberneticist. And again, the idea was to have a scientifically managed economy by using all of this information. Now, you might think those are kind of old-fashioned examples, but a more recent one is here in the UK. CitSen, it's called. It's next to the Cobra room, the incident room in Whitehall. And this is a quote from the BBC News story, kind of gushing almost about how people in central government can sit there with these dashboards and these huge screens and collect all of the information that's needed for them to respond to crises, but also to visualize data for everyday government purposes. Now, surely it's a good thing. And the pandemic made many people in government appreciate much more the value of big data because they could join up useful information about the economy, people's likely behavioral responses to lockdowns or to mask mandates, and also the public health data. So it gave a real push to government attempts to join up lots of different types of data. Office for National Statistics did this in its standard way by approaching private sector companies and using some of that to give us weekly surveys about what was happening to the economy. But one of the outcomes in central government has been the creation of what's called the Integrated Data Service, where they are joining up a lot of research data that currently sits in ADR UK that researchers here will know about, and a lot of government administrative data across different departments. And the idea is, of course, that it will enable government to make better decisions, deliver better public services. That sounds like a fantastic thing. But what if we had a different kind of government? What if you're somebody who doesn't trust the government? Is it not, in its own way, the kind of digital surveillance that people worry about? And there are lots of decisions to be made about these identities, these data identities that are being created for people. Suppose you are a child that grows up in what's called in the jargon a troubled family, that you come to the attention of school authorities or the health authorities in some way. And then when you're 18 and you've left home, should that tag troubled stay with you? Or should that data be thrown away? So This depends on trust in institutions, their legitimacy, and the way that power is distributed in society. Now, of course, there have been other societies where all the data gets joined up, and we've been worried about it. These images come from the Stasi Museum in East Berlin, which is just a fantastically interesting museum. They had a very strict data policy about who could access it, but it turned out that there was a lot of data and people in the central government could access it. And this is an image of how pervasive that collection of data about people was. Post boxes had cameras stationed at them. Everybody posting a letter was photographed. All of the letters were steamed open. And if something naughty was found, the poster, the person posting the letter, could be tracked back through the photographs. And there are amazing bits of equipment in the museum with special card files and special equipment for keeping track of all of this analog data. And so the term was Gläserner Mensch, transparent person. It all got joined up in this single identity. Now, we think this is a very problematic example. So do we think that our benign government examples, be it Aadhaar in India or here, are completely unproblematic? Well, probably not. And it's unnecessary. This synoptic view, this James Scott high modernist view is not necessary because it relies on this flawed construct of data as property and of single identities. But people don't need to know everything about me for me to go about my daily life. And what we ought to be thinking about is what's the right access that people can have to data for what purpose? And I would draw on this concept of privacy in public. You can be in a crowd, nobody knows anything about you. People only need to know certain things about you for certain purposes. Your doctor has your medical information, which is highly personal, but they're trusted and they have protocols and governance structures for looking after it. Similarly with your bank manager and your financial data. Any lecturer has certain information about their students, but they don't need to know very much. They don't need access to a big centralized database. So I would argue that we probably need to be thinking about ditching the property concept, thinking about who can access what data for what purpose, what's legitimate, and what's the governance around that. And in circumstances where data aggregation is useful, we don't use actual data, we use synthetic data, which is becoming increasingly possible. And that's data that's got the same statistical properties as the real data, but you throw away the real data. It doesn't need to be real people, it can be synthetic people. So that's the concern about too much data and joining up and being transparent or high resolution individuals. But the opposite is also bad. And that's being a low resolution or an invisible person. So there's a lot of data in transport, and Transport for London is a great example of a public body that makes big data available for other services to be built on it or just for sheer interest. And so here's a map of traffic flows on the tube. There's fantastic information because you tap in and out, and people use Wi-Fi, and the trains themselves have got information, have got sensors in them. But what about the journeys not made? What about the people who would like to go from one of the poorer areas of the city that are underserved by public transport, but they can't get to a job because the bus route's not there? The data, the digital data, is not a portrait of everything you might want to need to know about society to deliver good policy outcomes. And so one of the things you might want to do is go and talk to people who live in the areas of southeast London that are not well served and see maybe there are other bus routes that could run that would help them, or what might they like to do. That's not captured by any of these digital, easy methods. So there are a lot of questions about missing data as well. What are the classifications? What's the sampling frame? What's the bias? So these are well known, although not easy to solve. But also this kind of missing counterfactual data. What else might you want to need to know, and how are you going to find that out? So I think there are some specific issues in using data for in AI and for algorithms. So the first of all is, can you actually specify what the objective is? And often the aims of a public policy are multidimensional. They might even conflict with each other. Cass Sunstein has this concept of incompletely theorized agreements, whereby people can disagree profoundly about the ultimate objective of a policy, but still agree on intermediate steps towards attaining that objective. We might call it fudge if we were not being polite, or compromise if we were being polite. Where do you put the compromise in specifying your objective function for your algorithms? I did part of this talk at a computer science conference, and the computer scientist who came up after me said, oh no, that's not a problem because you just adjust the weights in your objective function to reflect the different aims that you've got. And I'm sitting there thinking, 52% for Brexit, 48% against. Can you weight those in an objective function? Probably not. Public policy is a terrain of conflicts of interest and fundamental disagreements. Specifying an objective function isn't always easy. Even if you can agree or you have a single objective, it might not be codifiable. And this is what's called the alignment problem. It's the same as the problem in new public management. You can specify a target, people would deliver the target might not be exactly what you want. And that's really quite a serious problem. The incompletely theorized agreements I've talked about, and then actually the way that the algorithms are often used assumes away all of the issues about social choice. We know that aggregating from individuals to that society is problematic, and the problem is assumed away. So it's straightforward homo economicus on steroids, utility maximization on steroids. So that's one issue, or one set of issues, about objective functions and setting up machine learning processes for policy decisions. Another is that they are correlational techniques. It's all about recognizing patterns. This is a deep learning structure where you have inputs, you have all this stuff going on in the middle, and you've got the outputs. It can be quite hard to tell what's gone on in the middle. And there are a lot of problems of causal inference that are well known if you're using small data and medium-sized data, haven't always translated into using big data. So things like structural change, making your parameters unstable, overfitting and model drift, all very familiar from people who are used to causal inference, not always being recognized in the use of these systems in decision-making. And then a third set of issues that I'm still thinking through comes from work that a student of mine is doing about looking at ethnicity in predicting what treatment paths give people better health outcomes for certain conditions. And depending on the information you give the algorithm about ethnicity, the outcomes in terms of how long do people have to wait for treatment vary greatly. And this raises, in my mind, a question about what is your objective function actually? Are you looking for the best possible outcome given the society that we have, which we know is biased, and yet at the same time we might want to recognize that certain kinds of bias have had adverse outcomes for groups of people? Do we not want to compensate for that in some way and therefore recognize their membership of those groups in the machine learning system? Or do we want to think about a better society? And I've put the French flag in the background here because the French do not collect data on ethnicity. And for a long time as a social scientist, I thought that's sort of weird because if you know that the prisons have overrepresentation of people from certain ethnic minorities, why would you not want to officially know that and devise policies to address the shortcomings that they face, the obstacles that they face in society? But maybe that is to set expectations too low. And maybe to think about optimizing decisions for a society with liberté, égalité, and fraternité is a better way to go. And I'm not sure at the moment what I think about that. So optimizing is really fraught. Welfare economics was a live area of economic research in the 1960s and 70s, and really hasn't been since then. And I think it's time that we start thinking about different kinds of objective functions in these contexts. Rather than old-fashioned, straightforward utility maximization, what would a Rawlsian machine learning system look like, for example? Because how people are identified in the data, how they're classified and identified, is shaping the constraint subject to which the maximization takes place. And I think that's a problem. So just a little bit more from me. What does that mean? What are the implications for when we should want to use AI in public policy? And I think there are some. So there are problems that you can worry about. You can worry about issues of data classification. Are the classifications the right ones? Is it omitting something important about society? Bias, which is a recognized problem but not easy to address, because even if you take out the variables that denote bias, that's often implicit in the other variables as well. Can you define an objective function? Can you think very hard about that and about how well the data actually measures your objective function? And then some other criteria as well. Is it a decision that's really going to affect people's lives? It concerns me that we're seeing so much use of these systems in criminal justice and in welfare, where the decisions have a very big impact on people's lives, and we don't know enough about whether they're good decisions. How important is the procedural fairness or the participation? Because these are top-down structures. This is the government holding the data about you and making decisions for you. Is the decision-making entity trustworthy? And is it actually trusted, in fact? Does it have that legitimacy? And then one that's not been much talked about is incentive alignment. So there are areas of use for these systems that are pretty unproblematic. And you can think about fraud detection. My interest and my banks are in preventing fraud. Medical diagnosis. My interest and my doctors are in diagnosing conditions accurately and early and so on. And then other areas where you might think incentives are very much not aligned. Credit ratings, autonomous vehicles. If there's an incident with an autonomous vehicle, who is going to bear the responsibility for that? Is it the pedestrian who gets hit for crossing the road in the wrong place? Is it the owner of the vehicle? Is it the manufacturer? And so on. So we can start to think about incentive alignment. And here I think there's a really interesting economic research agenda in thinking about how to apply mechanism design in these much bigger systems. And it's been used a lot in apps and smaller scale issues, but it could be used in these big systems as well. And then finally, thinking about data governance and data norms. And this balance between the private and the public. An example would be competition policy. Big tech companies find it highly profitable to have lots of data and to own it and not to share that. In fact, they sell data analytics very often. But open data and thinking about what part of access to their data should be enforced for reasons of new market entry is an empirical, a practical question. How can it be done legally? What is the scope of the access that should be mandated and so on? We've tried it in open banking, which has been a partial success. Should we do more of that? And then this point again about data access rather than ownership. We're thinking about who do we want to know what about other people in society to reach good decisions. The scope of what we can do has been increased tremendously by the gathering of big data records, the development of the systems, the availability of the compute power. But we need to think much more about the social underpinnings of that, what are the rights and responsibilities that go with it, and to do so not at the level of general principles about AI, but in specific contexts. So a lot of work to do. I think we're at a very early stage of this conversation about data policy. Meanwhile, we've got GPT-4 3 months after ChatGPT, and we'll probably get number 5 in another 3 months' time. So we better start having this debate soon. So thank you very much, and I'm looking forward to hearing from you. Thank you. It's my favourite T-shirt.
Thank you very much, Diane. That was wonderful. So some very thought-provoking questions there. You'd like to raise your hand if you've got questions for Diane. Any questions? Okay, we haven't got any at the moment, so if I'm allowed to abuse my position as the chair for the moment. So I had a question about the difference between data and knowledge. So it strikes me that you can make a very strong case to say that data, in the way that you spoke about it, has got these public good qualities associated with it. But in most decision-making contexts, data in that sense isn't really the most important thing. It's actually interpretation. What do people actually do with that data? And that can actually vary quite radically between people. And those interpretations, in a fundamental sense, are quite private, or perhaps they're communal within a kind of group. So I wondered whether you could say a little bit more about that distinction and maybe how that maps onto the kind of policy questions you were raising towards the end of the presentation.
Yeah, so you're absolutely right. People will want to use data for different purposes, so it's very context specific anyway. It's also pretty hard to use. The evidence from micro-founded studies of firm behaviour is that only 5% or so can use digital tools like data analytics to increase their productivity. So the most productive firms have been pulling further and further away from the others. And that's linked to what skills they have available, but also the processes inside the firm. Can they reorganize things to turn the data into knowledge? And it turns out that's pretty hard to do. So that's absolutely correct. I think the concern is really about the hype or the lack of understanding that it's tricky. And we saw some of this in the budget yesterday, and a number of recent reports about reforming government. It talks about data, that you can look at a dashboard, you can see that productivity in Rochdale is not very good, and somehow you can do something with that, but it's a really much more challenging problem. So that's the bit that concerns me the most.
Oh, it's a general question on privacy. You did mention there's a project in India collecting personal data called ADA, and what sort of concerns, maybe could you elaborate on that? What sort of concerns have been raised about that project?
So the concern is, the project is a digital identity project. So it allows people to use biometric information, fingerprints, iris scans, to identify themselves as, let's call them a number 3,226. And that's the identity that allows them to access government services, pay their taxes, get a bank account. So it now determines access to services. Now that's probably fine. It's making life easier for people in some ways. But there are two concerns, really. One is that this is a centralized database about everybody in the country. Pretty much everybody joins it. That's such a honeypot for bad actors. And so the security around that has to be enormous. And then the other concern is about, India is a democracy, but it's a democracy that's very divided, and there are concerns about government actions and government invasions of privacy. So it's the surveillance debate. It's not capitalism, it's not Google who's got it, but there is that basic privacy concern about any single synoptic database about a population.
Hi, I'm really curious about what type of data would be collected by or reflected in national accounts. So that is my first question. And then the follow-on question to that is, what does it mean for nations in the global south that are nowhere near this point of having digital data? I mean, there's some countries that have no digitalization yet.
So the way they're doing it in the national accounts is what's called a sum of costs method. They're thinking about how much does it cost to create the data, looking at the labour cost and the capital cost of doing so, because that will give you a sort of minimum level. People might use it in different ways, they might create different amounts of value out of the ways that they use it, but that gives you a kind of minimum, because you presume that on average people aren't going to be assembling data that isn't useful to them. So it will be there, and that's valid because if you think about it at the level of a company, the market capitalization of data-intensive companies is much higher than that of companies that are not using the data. So there is an economic reality to be reflected. For countries in the global south, the manifestation is more often about data localization. So Facebook, Meta, and Google might be collecting a lot of data from the apps that people are using. So the policy direction is that that has to stay in data centers that are in the country. To me, that slightly misses the point. You would want to have governance around whoever collects the data so that it's legitimately done with agency, enough agency for people and enough security. But it's only going to be valuable if it's used. And so data about the Indonesian population is only going to be valuable to create goods and services that are sold to the Indonesian population, unless you think that the whole world has become homogeneous and it doesn't matter, which is clearly not true. But this does amplify the digital divide that we've been talking about since the 1990s. And the dynamics are such that these divides get reinforced over time. You know, if you've got the data and you know how to use it, that advantage is probably going to get reinforced unless there are some interventions. So data policy is high on the agenda of the G20 at the moment to think about exactly how should lower income countries respond to this and how do they need to tailor their data policies.
Thank you. I left the civil service last year, so everything you described about the recognition of the necessity to use data properly rang true. One of the challenges we had was all the skills gaps from the not numerate enough generalists to not enough economists to not enough technologists who knew how to build the models, let alone understand them. And I was just wondering whether, given some of the challenge you described, do we have the same challenge in academia of building multidisciplinary teams of ethicists, lawyers, technologists, economists, or do you feel quite positive about the fact that this challenge has driven some of that interdisciplinary work?
It's a great question. Do you need to bring together a bunch of different disciplines to tackle these problems? Of course you do. And anybody who researches this area is frustrated about how few people in government understand enough about it to get into the granularity of the issues, because there are lots of difficult choices to be made. I was on the Furman panel that looked at digital markets and competition here in the UK. We had a technologist as well as lawyers and economists, and could not have done what we did without understanding the affordances of the technology and the scope for opening data or making it interoperable. There are promising signs in academia, but not enough. I'm kind of obsessed by how hard it is to do interdisciplinary work anyway, because all the incentives are stacked against it. There are some large bids at the moment around AI that are interdisciplinary, and I'm on one of the bidding consortia. But not enough. You know, economists are quite excited now about big data, but that's because economists tend to be techie guys who, you know, like having to learn new computer code, and so it's not quite what we need. So, you know, absolutely spot on.
Thank you very much for the fascinating talk. I have a comment and a question. You mentioned the typology of goods or resources in terms of rivalry and excludability, and I think following up on the sort of institutionalist work of people like Lena Rostrom, it's also important to consider more dimensions than just rivalry or excludability. And one of the obvious ones here is the level of co-production, in a sense that it's the users that are providing necessary, indispensable, complementary inputs into producing the data. So when I make a search on Google or Amazon, I and Amazon, we are co-producing the data. And I think, and this is the comment, I think there is a sense in which it is still the idea of property that applies, but property is not just full ownership that amounts to alienability or excludability. But I think even if we talk about the rights of access to the data, we're still talking about one important bundle of property that applies. So I think I think your argument is more against commodification and more against selling the data rather than getting rid of property as a concept on its own. But my question here is, to what extent do you consider that the work that is then done by aggregation of that data on the level of Google or Amazon is not in itself a created and a valuable contribution in that process of putting the data together and creating some kind of an insight or maybe even interpretation or seeing some kind of a pattern that then would justify benefits or compensation on the part of whoever takes part in this procedure?
Thank you for that. So I would agree with you, and I should have been more careful to talk about bundles of property rights, I think, and rights of access I would accept could be denoted as a property right. I'm not sure I'd use the word commodification, but I completely accept that point. I'm not arguing that Google is not creating value. I'm arguing that it's creating value in a co-produced way, as you put it, and the debate ought to be about how much of that value gets retained by Google. And certainly would not argue that they should make all of their data open to everybody freely. They have invested, they have lots of brilliant engineers, they should get some return for that. But they have used their data to create a moat that stops new entrants getting into the market. So we're not at the right place on that division of benefits. How do we begin to think about what we should require them to make publicly available?
Just a very quick comment on your last remark. It sounds as if you were describing a utility.
Yeah, it's a debate we had in the Furman panel. There are a number of approaches you can take to the political and market power that big data companies have assembled. Lena Khan has argued for breakup. The problem with breakup is that that reduces some of the consumer value that's created by the aggregation. We argued for a series of measures that would enable entry into the markets and make the market work better. That might not work. And if that doesn't work, then I think the third option, which is treat them as utilities, is definitely another one to consider. And this phrase is digital public infrastructure. What do you consider to be the infrastructure level? What level of the technology stack should be regulated and mandated? And on top of that, you can then have the competition. And again, I think that's not an easy question to answer. And it's played out in different ways with previous technologies. With DVDs, with Blu-ray and VHS, Betamax and VHS, sorry, that was the competition in the market, which VHS won. With mobile telephony, that was a kind of mandated, legislated technology level on which the whole mobile phone industry was then able to grow in an initially very competitive way. So the detail matters a lot. And I mean, to go back to the earlier question, the capacity of the policymakers also matters a lot. I started by saying I was in Silicon Valley last November, and one of the big tech guys I was talking to said, the trouble with government is there's no there. We know there are some problems, but we don't know who to go and talk to about them because the language, the shared language and understanding isn't there.
Hi, I guess I have a bit more of a governmenty question, which is the UK right now, we're working a balance of trying to position us to become a signed superpower, and equally so many rural and coastal communities don't have access to basic minimum broadband. So my question is, as far as supporting infrastructure is concerned, where should our priorities as a government be to position ourselves to both harness the benefits of big data as well as protect us from its perils?
Oh gosh, that's a big question. If you're requiring people to do anything, any interactions with the government online, then you have to ensure that they have online access. So I think basic infrastructure is absolutely fundamental. It can't be done at a profit. It will have to be subsidized. There's a broader question about minimum level of infrastructure for all of our communities around the country, and many don't have it. So there's that. And then I think the other part of your question is just too big, really. You know, it's all a question of detail about these different domains. I've talked about personal data. There's a whole other set of debates about business data, business-to-business data. For example, in construction, you can put sensors in tunnels so that you know in advance if there's a problem, the maintenance is reduced, the time lost is reduced, costs are cut. Who's going to get the benefit of that? What data sharing is permitted under competition law along the supply chains? So in every domain in which data is important, there are just lots of detailed questions to be ironed out, and we are only at the beginning of doing so.
More hands going up. I've got another question, if I'm allowed to. So this is a little bit facetious, perhaps, but it's thinking about maybe some of the issues with thinking about data in this way. So there's a tendency, it seems to me, when people talk about data in this way, to believe that if only we have more of it, that we will get better outcomes. And I'm not entirely convinced about that. So I think the example that I would give, I'm not sure whether people are familiar with this, and I'm not actually sure the name of the guy, but I think one of the people who was the governor of Hong Kong at some point in the 50s or 60s, he actually banned the collection of governmental statistics on the grounds that this would actually just encourage people to be classifying things in certain ways that were actually useless. And you might say, well, Hong Kong did pretty well without having that data. Now, I'm sure they've been collecting it since. But there is a point there, and I think it actually relates even to the issues you mentioned at the end about gender, sexuality, race, these kind of questions, where there's a huge scope for kind of misrecognition of people, that people will be classified in ways that don't actually really relate to the way that they live their lives. And in that case, isn't this just a kind of gimmick for the people who like playing around with numbers and collecting them? But it could actually have these quite damaging consequences.
I agree with that. I think we ought to have the debate about what data we're going to throw away. And bigger is not always better.
This might be a bit of a silly question, but I was thinking about, first of all, when you said that the UK government is including data in its accounts, and that the market capitalization of firms that use data is much higher, and who should reap the benefits of the code data, and should we actually trim down on our data? Is there a room for some sort of data tax where you tax companies based on how much data they have to encourage them to strip down on data that is not useful, to encourage them to have less data so that other firms can enter more easily, and to increase government revenue that can then return some of the money that is made by the co-production of data to society as a large?
That's an interesting thought. I don't know about taxing data, because it would depend on the data, I guess. You could make a case for penalising security breaches, because the cost of acquiring a lot of data is that bad actors will try to access it. There are not many markets for data, but the one that does exist is on the dark net, where people's identities and bank account numbers and so on are transacted. So you could make that more costly, and that's a sort of tax of bad data behaviour. I've often thought about a tax on advertising, because one of the purposes of collecting a lot of data about consumers is to gain advertising revenue, because you can personalise the adverts. That's what drives a lot of the toxic behaviour online. It's wanting clicks to go viral, because that gives you more advertising revenue. So taxing the ad revenue, I think, might be a very interesting thing to think about. And it's something that Paul Romer at NYU has also written about.
Any more questions? No? Well, in that case, before we actually move to thank Diane for the presentation, I'd just like to mention two more events that we've got coming up at the centre in the next couple of weeks. So next week, on Thursday, 23rd of March, we've got a book launch event for my colleague, Dr. Brian Chang. So he's going to be launching his book, Economic Liberalism and the Developmental State, Lessons from Hong Kong and Singapore. So that's basically a week from now, Thursday, the 23rd of March. And then on April the 4th, we've got Professor Terry Flew from the University of Sydney, who's going to be talking about cultures of advanced liberalism and platform governance, which actually has quite a lot of overlaps with what Diane's been talking about. But for now, I'd just like to thank you all for coming today. And most important of all, thank you to our speaker, Professor Diane Coyle.
Thank you.